is my preferred method to solve systems. I use elimination more than anything, except in special circumstances. But the reasons that elimination works are a little bit more complicated than the reasons. I'll have a blue Christmas without you. The reasons elimination work are more complicated than the reason substitution works. So I take a little bit of time to show you why elimination works, because it also gives me a chance to double check your ability to graph. So first thing, on that grid you have there, please give yourself a set of axes, if you would be so kind. And then, please, if you would be so kind, graph these two equations. La 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 la. Red one first. And you should all find that the system has a solution where the lines cross, which is, of course, right there, which is 3, 3, -4. Everyone agree? Everyone can graph those, yes? Yeah? Yeah. Or if we're all driving Volkswagens, yeah. Now, this next thing is very important. Choose a number between 1 and 10. Don't tell me what it is, just choose it. Write it down, and then do this right here. Okay? So choose your number, multiply the blue highlighted equation by that number. Okay? And then write your new equation right down here. I'm going to use 7. So I'm going to get 7 times 5x minus 3y equals 27, right? So when I multiply it by 7, everything has to multiply by 7. So my new equation is 35x minus 21y equals 189. And I'm going to highlight that one blue because that's my new equation. Is everybody cool with that? Did everybody do that? You all chose a number? So unless you chose 7, you should have a different equation right here, correct? Okay. Now, do this. Solve that equation for y. What does solving for y mean? It means gets y isolated. So I'm going to go ahead and do that here. 35x minus 189 equals 21y. 35 over 21x minus 189 divided by 21 is negative 9y. And then when I simplify that fraction, I get 5/3 x minus 9 equals y. And all of you should have gotten the same thing if you did your algebra correct. What correctly? What do you notice? It's the exact same line. So, what does that tell you? Just like fractions, if you multiply every part of an equation by the same line, you're going to get the same line, correct? What does that tell you about division of that same line? What are you going to get? Well, in fractions, if you multiply everything in a fraction by 3, you get the same fraction, don't you? What happens if you divide everything in a fraction by 3? He waited patiently. Same fraction. Cool? Everybody understand? So, what's the first key point? Multiplying both sides of a linear equation results in the exact same graphed line. But, and I like big buts, thank you, Antonio, because I wrote it in capital letters. Yes. Of course I record it. That's why my math lessons are classified as comedy, not education. And I blame one of you people for that. Somebody reported it to YouTube as comedy. No. All right. Now, so that's one piece of thing we have learned, yes? We can change the way the equation looks by multiplying it. But we still get the exact same line, yes? Everybody cool? All right. So let's do this now. Add these equations. So you remember how to add equations from polynomials. What's 4x and 5x? 9x. What's 3 minus 3? He waited patiently. Just like it says here. Negative 3, plus 3, minus 3. 0. And 0 minus 27. Or, sorry, 0 plus 27. 27. And now, what do you do with that? By what? 9. So x equals 3. What happened to our equations? The y variable did what? Disappears. And we get a new line. Correct? Everyone agree? Now look, you don't have to turn this page back because I just heard you all turning pages. I didn't realize you were on the next page. Where is x equals 3? Right here, yes? Right? And x equals 3 is a vertical line, isn't it? Where does that vertical line go? Right through our solution. Does everyone see that? You don't need to graph it, but you all see it, right? So what does that tell us? We'll do the next one before we do that. Let's see what happens if we do the next one. Let's subtract them. What's 4 minus 5? Negative x. What's 3 minus minus 3? That's plus 6y, yes? And what's 0 minus 27? Negative 27. Everybody cool? Graph it, or isolate y. 6y equals negative x, positive x, minus 27. Y equals 1/6 x minus 27 over 6, which is 4.5, right? Does everyone agree? Does everyone agree? Can I graph that? Okay, you all know how to graph it. I'm going to go back and graph it and watch what happens. 1/6x minus 4.5. There's 4.5. I'm going to change to green. There's 4.5, yeah? Up 1 and out 1, 2, 3, 4, 5, 6. And where does that line go through? This. But everybody knows where the line went through, right? Where did it go through? The same point, right? Does everybody agree? Okay, so what did that mean when we added or subtracted? We ended up with results in 2 new equations. And I'm being lazy. I'm only writing EQNs. 2 new equations which both go through the same solution. Nice type spelling. Go through the same solution coordinates. So what does that tell us in general? Can I multiply equations and keep the same solution? Yes or no? Yes. Can I divide equations and keep the same solution? Yes. Can I add equations and keep the same solution? Can I subtract equations and keep the same solution? I shouldn't say keep the same solution. Find the same solution. Everyone agrees? Okay. So, just to make sure, can you guys tell me one other equation that will have the exact same solution as these two? You could add them, you could subtract them, you could multiply them, or you could divide them, and you would have the answer, right? So if I multiplied them by 2, would I have the same solution? So that would be 6x plus 4y would equal 36. Everyone agree? Multiply by 2. Could I do 1/2 x minus 1/2 y equals 1/2? Divide, divide, divide. Right? Everybody cool? Everybody cool? Yeah? Everyone is good? Yeah, everybody is good? Okay. So, this leads us now to my preferred method for solving systems. It's called elimination. Now look back. Don't you look back. Just look at what we did. Right here, when we put the solutions together, what happened? Or put the equations together, what happened? What happened to y? It disappeared, which means we were left with a situation where we only had one variable, right? And that we know how to do. And then once we got that x, where can I put that x now? Anywhere I want in these equations and find y, can't I? Does everybody see that? It's one step shorter than substitution. So, here we go. First step, add or subtract to get rid of one letter. So, which of those 2 letters can I get rid of in one step? Why can I get rid of y, Antonio? Why can I get rid of y? They have the same coefficient, right? So if I add these, what's 3 plus 4? 7x. What's negative 5 plus 5? 0, so it's gone. What's negative 9 plus 23? What kind of 14? Positive 14, right? Everyone agree? What are you going to do with that? Divide by 7. So what does x equal? Now you have one of your coordinates, don't you? Now where can I put that 2? Into any other x. Does it matter which one? No. I'm going to put it in the top one. So what do I get? 3 times 2 minus 5y equals negative 9. 6 minus 5y equals negative 9. Negative 5y equals negative 15. Y equals 3. Is everybody good? So what is my x and y? 2, 3. I've already checked the top one. It worked, right? So what do I got to check? Just the bottom one. What's 4 times 2? 8 plus, what's 5 times 3? Is 8 plus 15, 23. So we've solved it. Do you all see why I like elimination better? It's only 2 steps. Now, here's the weird thing. Some years I teach elimination first. And the kids then I teach them substitution. And every kid says, why wouldn't you start with substitution? It's so much better. So the next year, what do? Start with substitution, teach elimination second. Then what do all the kids do? Why would you teach us substitution? It's so hard. Elimination's so easy. I know that. I know why it is, Antonio. Because every question for you guys is new. Oh my God, I don't know how to do this. Because back in the day, you used to get 1,000,000 worksheets on something and then you knew how to do math. Now, worksheets are bad. They're not very sexy. Don't make kids repeat. Don't make them memorize, you bastard. Anyways, now, look at the next one there. This one. What's weird about it? There's no same coefficient to eliminate, is there? But wait a minute, the very first thing we did was change the way equations look, didn't we? So what can I do to change that so it works? If I multiply this top one by 2, what do I get? 2x minus 4y equals 14. Can I eliminate now? Okay, don't do it yet. Could I also have done this? Multiplied it by negative 3, which would have given me negative 3x plus 6y equals negative 21. Would either one of them work? Does it matter which you do? So is there a way to do this, or is there a method to do it? There is a method. What do you have to learn? The method or the way? The method. Okay, because I would have used 2 for the simple reason that I wouldn't have had to have a negative in my multiplier. Okay? That's why I would have done it. But since I've already got this written here, this is the one I'm going to use. So what do I do now? Adam, what's 3 plus negative 3? 0, gone. What's 4 plus 6? 10. And what's 1? 10y. Now, this is where you're going to get screwed up. What's the answer here? 1 and 20, negative 21. What's the answer? Negative 20. So what does y equal? Negative 2. Where can that y go now? anywhere you want. It doesn't matter which equation you put it in. So 3x plus 4 times negative 2 equals 1. 3x minus 8 equals 1. 3x equals 9. X equals 3. What's my solution? 3, negative 2. I checked it with this one, right? So I better check it with this one. 3, what's negative 2 times negative 2? 3 plus 4. Does 3 plus 4 equal 7? So I'm correct. Now, look at that one. And tell me what's weird about it. I can't multiply one thing, can I? So what do? Multiply both things to get them to the same number. Have we come across this anywhere? Where we have to have two different numbers and make them the same? What would you do with that, Sammy? How would you add those fractions? So you would take these two different numbers and make them the same, wouldn't you? You could do it that way. So if I multiply this side by 2, what should I multiply this bottom one by? What kind of 3? Negative 3. So what does my top equation become? 4x minus 6y equals what? 40. What's my bottom equation become? Negative 33x minus 6y. Uh-oh, I screwed that up. I shouldn't have used a negative. Right? Right. See? So I said we got to multiply by 3, right? And then you're like, oh, but it's got to be subtraction. You guys all negative 3, so I wrote negative 3. And then when I worked it out, I saw that it wouldn't work, right? I saw that. So do I keep going? No. So it has to be positive. So this becomes positive 33. And what's this become? Negative 3. And then what do? Put them together. What's 44 and 33? 37x. This disappears. What's 40 minus 3? 37. What does x equal? 1. Now what do with that 1? Anywhere there's an x. Does it matter which one? Nope. 2 times 1 minus 3y equals 20. 2 minus 3y equals 20. Negative 3y equals 18. Y equals negative 6. What's my answer? 1, negative 6. Which one do I check? The other one. What's 1 times 11? 11. What's 2 times negative 6? Negative 12. Is 11 minus 12 negative 1? So are we correct? Everybody good with elimination? Now listen to me. I don't care which one you use if I give you a math problem. But you need to be able to show me that you can do both. You understand what I'm saying? Because sometimes substitution is the better one to use, and sometimes elimination is the better one to use. But they both will always work. Understand? If there is a solution to the system, one of those two methods will always work. Now, what was the key little word in that sentence I just said? I'll say it again. Either solution, either method will work if there's a solution to the system. If. What does that tell you? There might not be a solution. Everybody understand that? And here is what I mean by that. Turn your page over, please. This takes 5 minutes, then we'll be done. If I was going to graph that, what methods could I use? Could I do a table of values? Could I do slope-intercept form? Could I do x and y intercepts? Does it matter which one I use? No. I, of course, am going to slope-intercept form. So that is going to be 4y equals negative 3x plus 24. Y equals negative 3/4 x plus 6. 1, 2, 3, 4, 5, 6. And negative 3/4 down. 1, 2, 3, 1, 2, 3, 4. Everyone agree? Everyone's happy with that? Yeah, I went to positive 6. And I went down 3 and out 4 because it's a negative slope. And then my blue line is going to be negative 3y equals 6x minus 33. Y is going to equal negative 2x plus 11. Now, that doesn't work very well, does it? Why? Plus 11's off the graph, isn't it? So if I go up to 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I'm 1 off the graph, aren't I? Everyone agree? But I got to go down 2, 1, 2, and over 1. So there's my first point. Everybody happy? Down 2 over 1, down 2 over 1, down 2 over 1. And there is my solution, right there, where the blue and the red dots meet. And that is 4, 3. Is everybody happy with that? Everyone's happy? It's got a solution, doesn't it? Right? And how do we know it's got a solution? Because what did the lines do? They crossed, right? How do we know they're going to cross? If two lines have different slopes, what does that mean? They will cross how many times? They will cross once somewhere. So as long as the slopes are different, they're going to cross eventually, aren't they? It might be out at x equals 1,000,000, but they're going to cross. Everybody understand? As long as there is a different slope. And we saw, indeed, that these had different slopes. Everybody cool? Everybody cool? Okay, look at the next one. You don't actually have to graph them. Let's just do that. 4y equals negative 2x plus 12. Y equals negative 2/3 x plus 3. Agreed? Everyone agree? So, quick graph, down 2, out 3, down 2, out 3. That's what it's going to look like, right? Sim. Oh, I should have divided by 4. Such an idiot. I remember to divide 12 by 4, but not that one. So it's down 2, out 4. Which is the same as a half, yeah. Thanks, Sammy. Now, what's the other one? 2y equals negative x minus 12. Y equals negative 1/2 x minus 6. Down 1, out 2, down 1, out 2. What's going to happen there? They're never going to cross. Why? Same slope. And same slope from our last unit means they are what? Parallel. What does parallel mean? They're never going to touch. So if the slopes are the same, do I still have a system? Is that two equations? It's still a system. So if slopes are equal, no solution. because they'll never cross. Everybody cool? You already know this, right? And finally, guess what this one's going to be? 3y equals negative 2x plus 5. Y equals negative 2/3 x plus 5/3. Right? And the other one, quickly graph that. 5/3, 1, 2, 3, 4, 5. There, 1, 2, 3. That's 1 because I've changed the scale, right? Then slope of 2/3, negative. Everybody cool? Okay, what's this guy? Divide by negative 6. So I've got negative 4/6 x minus plus 10/6 equals y. What's that? What happens when I reduce those? Or simplify them, I should say. What do I get? Negative 2/3 x plus 5/3 equals y. So if I was going to graph that line red, where would it be? Exact same, right on top of that. How many times would those two lines cross? Infinite, because they're the exact same line. Do you all understand? So what's the conclusion there? If the equations simplify to the same equation, I have infinite solutions. And I'm done for the day. Infinite solutions with an M. Infinite solutions. Okay? Your job is to do these questions that I've just asked you to do. Don't graph them. Don't do elimination. Don't do substitution. Tell me not the solution. Tell me if there's one, none, or infinite. And practice some elimination questions, which are these. Page 437, 1367. I don't think you need to practice properties of a system, but there is some questions for it. You will not see a test on systems, but you will see some questions on your final on them. Do you understand? Okay. So if you want to have a look at 448, go ahead. Tomorrow, we'll do that last thing, and then we'll spend Thursday and Friday reviewing for the year. All right? Now, before I go on, and I'm still recording, so you'll all be able to hear this and not hear me, not say to me on Thursday, you didn't tell us to do that. On Thursday, during regular class, you need to come here with an idea of what it is you are bad at. Do you understand what I'm saying? What you need to review. You're not allowed to say everything because there are some things you did better at than others. If it is everything, then you know the path that you are going to be taking next year in math class. All right? If it is not everything, then you still have some options open to you. Those options being Pre-Calculus 11, Foundations of Math 11, or Math 11 A and W. If everything we have done this year has boggled your mind, you do not have an option. You will be going into Math A and W, which is not a problem in any way. You will still graduate, but you will need to upgrade to do just about everything after high school. Okay? No matter what you want to do. Any kind of post-secondary training or education will require you to have Math 11 Foundations at least, or pre-calculus. Now, some of you are smart enough and you're already thinking, wait a minute, I'm only in grade 10 and I only need a grade 11 math to graduate. So I have the next semester of grade 10, 2 semesters in grade 11, and 2 semesters in grade 12. You have 5 semesters to pick up that one thing you need. So if you do end up in A&W Math 11, that uses up one of those semesters, doesn't it? Either next semester this year, you could get transferred, or first semester in grade 11, yes? Leaving you with 3 semesters to get foundations or pre-calculus. Do you understand what I'm saying? So you are in no way hamstrung or shackled by having to take A&W 11. Do you understand me? Okay? Unless, of course, you fail A&W 11, then you're in trouble. But then, even still, you have 3 more chances to get it just to get your graduation out of the way. Okay? But I will warn you of this. I used to teach night school. 30 adults in the room. All of them in the room because they did the exact same thing. And this is what they did. They said, I hate math. I don't want to bother doing it. I'm going to do A&W just so I can graduate. They graduated. They left. They went out in the real world and realized, flipping burgers sucks. I want to be a nurse. Or, I've worked for my dad for long enough. I want to go be my own plumber. And they found that they couldn't get into BCIT with A&W 11. And they had to come back and try and do Math 11 5 years after being out of school. Now, you guys have trouble doing math 5 minutes after you leave this room. Right? I'm not putting you down. You just don't practice it enough. That's because you're busy. I get that. But imagine taking 5 years off it and then trying to come back. Do you understand what I'm saying? Because not only have you taken 5 years off, it also costs you money. How much is this costing you? Right? Nothing. Okay? Don't realize in 5 years that, crap, I want to be an electrician. Crap, I want to be a pilot. Crap, I want to do anything. And then have to come back and A, pay money, and B, try to do it without any help. And C, if you think that you don't get enough help from me now, and you go back to a night school course as an adult, you think there's going to be any of this? You think there's going to be any retests? You think there's going to be any X blocks? You think there's going to be any of the stuff that we bend over backwards so you guys can pass? No. So please, please, please choose wisely. Okay? I will be recommending each and every one of you for the course I think you should take. Some of you will be surprised that I say go do pre-calculus 11. Oh, I don't want to do that. Then don't. I'm just saying I think you could do it. Some of you will say, well, I need pre-calculus 11. I'm going to be a doctor. Okay. But then you're going to have to work a buttload harder than you did in here. Understand what I'm saying? Everybody cool? All right. So that's where I'm done. You guys can work on. I highly, 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 highly recommend you get 437 done. The properties of systems, you almost don't even need to do it. You just need to kind of look at it a little and get your head around it, right? As long as the slope, but make sure you do those 3 in your notes. Okay? Everybody Gouda? Go. Yo.